For the introduction, I probably speak Malay. You understand it's not important because the answer is from the Razlan slide later. Terima kasih kerana datang ke sesi Colloqium. Pertama yang dianjurkan oleh Kolej Kejuruteraan pada semester ini dengan harapan untuk menyebarkan pendidikan yang terbaru dan terkini yang dilakukan oleh para akademik kita. Saya sebagai saya daripada kluster industri dan Prof. Razlan sebagai speaker akan menceritakan tentang tajuk pendidikan beliau, iaitu Tool Design and Development, Current Progress and Future Research. So, saya akan memperkenalkan Prof. Razlan. So, Prof. Razlan banyak ni. Kalau saya baca semua tak boleh puluh minit. So, saya ringkaskan, cuma ringkasan.
Setengah jam.
Just summary from Prof. Razlan achievement. Prof. Razlan, Prof. Razlan holds PhD from Sheffield University in 2010. Before that, sebelum itu beliau belajar peringkat ijazah dan master di Malaysia. Dia juga seorang telah bergelar professional engineer daripada yang diiktiraf oleh BEM, chartered engineer daripada IMG, pernah memenangi UMP Supervisor Award engineering category, dan beberapa tahun Excellence Service Award, beberapa tahun cendekia bintara, beberapa tahun lebih daripada 3-4-5. Sekarang beliau adalah Profesor UMP Senate Member, Deputy Dean. Jawatan dia yang pertama sekarang adalah Deputy Dean IPS, Institute of Postgraduate Study. Pernah menjawat Deputy Dean Akademik di FKP dan Faculty of Manufacturing Engineering. Research beliau bertajuk Smart Manufacturing Tool Design, Vibration. Beliau telah memenangi beberapa research grant di peringkat ketua kumpulan FRGS, Fundamental Research Grant Scheme, Prototype Research Grant Scheme, MTUN grant, E-Science Fund, with an excess amount of 1 million Malaysian ringgit. Dr. Razlan telah memeriksa 24 PhD, postgrad atau master dan master. Dia telah menggraduatkan 5 orang student PhD, 10 master dan countless final year student. Sekarang student dia adalah 6 orang PhD student in progress. Telah menerbitkan, telah menulis 15 buku dan beberapa puluh jurnal. Dia juga adalah MQA, EAC, ETAC panels, dan juga external examiner dan advisor untuk beberapa 10 technical institution dengan Universiti Malaysia. Dia juga pernah menjawab guest atau visiting professor di beberapa universiti di Turki, Indonesia dan Jepun. Di dalam industri beliau telah menjalankan kajian ataupun menjadi ahli pendidikan di atau sebagai research fellow beberapa syarikat seperti Sirin, Sapura, TT Electronics, Binaan Gas Jaya. Itu antara pencapaian yang cemerlang oleh Prof. Dr. Ahmad Razlan. So jadi tanpa melengahkan masa, saya ingin persilakan Prof. Dr. Ahmad Razlan di Yusuf untuk menceritakan bidikan yang dilakukan oleh beliau. Dipersilakan.
Terima kasih. Thank you, Dr. Zamri, for introducing me. And today we have our dean, professors, and dear lecturers, and also the deputy dean. Thank you for inviting me to present what I have did last 10 years. So ini adalah hasil kerja selama 10 years. Saya accumulate some of it in one term on the two design itself. And we have inside this presentation, kita will have a 3 project. We deal with the two design mainly relate to the machining tool. So here yang dalam cerita tadi, overall about me. And for today's saya perhatikan kepada divide into 5 punya sections. First about the current trend of Industry 4.0, and the first project will deal with the milling tool. The second project on the deep drilling tool. Last project on drilling tool, and also what our future forward on the current project. Okay, about this Industry 4.0. Okay, in Malaysia they have a national policy. Okay, officially launched last year or last 2 years about industry forward. So here all the enabling technology. So most of us should prefer this one as you punya initiative on the mainly on the technologies advancements on the big data, AI and augmented reality, and the rest akan jadi enabling punya products. Okay, this not only relate to the research, tapi kalau ikutkan on the ESG manual, also when we revise the strategic plan and the program itself, we need to consider this Industry 4.0 elements. So similarly, kalau doing invitation, they will ask about this thing in your program. Itu soalan yang wajib. So this mainly the element tadi. Okay, on the we should encourage our syllabus yang akan ada on the electrical manufacturing, AI, big data dan sebagainya yang relate to the mechanical and electronic manufacturing. Dan mainly yang lain tu mungkin relate to the electrical electronics. And on the dia blueprint tu dia highlight on the Malaysia punya status. We actually in the good punya starting point where if according to the report here, okay, we are in the quarter on the moderate quarter here as compared to the France, Poland and other state university. So we are good right track, okay, to grow forward the Industry 4.0. The thing is up to us, for the lecturers semua, how to we need to change yourself, or if you know something you need to learn. Okay, you can have a training and how to get you punya add-on punya research these elements. So on myself, okay, we focus on the Industry 4.0 where in the manufacturing itself, okay, for my setup, I punya allocation is mainly on the machinery and equipment side. You can see from these definitions, and then of it we have the one on the machine tool that the main thing. So itulah yang kita akan cerita ini, the main tool. So we focus on the machining itself. So the first project is on the triangular machining tool. So we talk about this application on the industry. However, we as engineering college, we need to focus on theoretical. Basically, from the application, it should base on the theoretical. So my base theoretical mainly on the vibration itself. So that's why in the introduction, Dr. Zawi introduced me about vibration, where during my study in Sheffield, we need to take or capacitate 2 courses fundamental on the vibration in order to enhance your knowledge. So the same thing, you should apply or encourage the student, okay, PhD student mainly, if the body of knowledge of their research is certain things, so they need to take the class as fundamental to enhance their knowledge. So myself, so theoretical based, so this one about the chatter vibration, we have high productivity, maybe for the all company or all production high productivity. However, for this machining problem, it has been a dynamic deflection of the tool which generate unstable cutting. So from the figure itself, here the turning process, and here the milling and the drilling. So you can have, for unstable cutting, you will have a phase in-phase behavior. So they have analytical method to derive these chatter vibrations, where it can be defined also as a sudden vibration amplitude, when the input energy exceeds the energy dissipated from the system. Or the other definitions, dia buat juga adalah tentang self-excited vibration, where this vibration is the same definition actually. When you have high productivity, means the chip or the metal rate is too high. However, it causes the inconsistency of the dynamic system. So in theoretical vibration, you can have stable, no vibrations. You can have force vibrations, chatter vibrations. The main problem of chatter vibration, because we have out of phase, in phase a wave kita sama, compare dengan force vibration dia sama, dia akan menyebabkan unstable force happens. So this is the untuk close to diagram. Okay, when you have cutting, initial cutting, but before that they have delay of certain time where they cause the vibrations. So based on this phenomena, it will cause these problems. So maybe the problem of machine tool damage, the tool itself breakage or wear, and also when you try to produce from machining the product, it will out of their dimensions, and also the main thing is the surface finish. So from this definition and algorithm definition of the closed loop machining, so we can have this chatter schedule. So this schedule is a special analytical program to make predictions based on depth of cut and spinner speed. So you have nonlinear simulation software, analytical model, so to predict either your cutting or stable or unstable. So means at the same depth of cut, but you have 2 different speed here. So one is unstable, one is stable. So this one is unstable. You will have your high vibrations and also the surface finish. And so you have chatter vibrations. Compared to this one, you can have a higher production with a good quality of product, machine product, and also less wear of the tool. So here the input parameter you need to use, you need to have your cutting stiffness, the motor testing as vibration or dynamic properties. At the end of it, you solve this eigenvalue in the vibrations, so you can predict either based on this diagram, either stable or unstable. So here poor, so finish, a good to finish. So based on this concept, so we implement on the ramalan getaran kerja stability to predict, and we apply artificial intelligence, facial evolutions, you can have other team generated algorithm or whatever optimization software that we buy. Prozoid also can have. So to change the two geometry, and then we to get a new two geometry. For our cases, so this is a cutting tool. Okay, for example, you have a tool, any tool, a fork tool. Instead of similarly, equally 90 degree, each you have four tool here. However, for our cases, we have irregular. We will have different helix, different pitch here. Okay, the angle not same each other. It's not means 90 degree. So based on this formula everything, so we try to find the optimum value of the parameters. This example of Sakura project, we compare 12 and 20 million tool. So mainly we get the result where you have compare regular and variable, where you can have high depth of cut compare for the both tool. Okay, with the similar cutting speed. So maybe we increase more than 30%. So here our tool we develop. Okay, this is tool. Okay, and this is the 12 and this is 20 tool with the 8 flute. This one we mainly use for Sakura project. And when we compare in terms of surface variation here, you can see the difference SA, surface topography. Almost you can see 42% comparable. This is the uncoated and coated tool, usually for the 16 and 12. And for this project, we apply the platform benches and also get 3 intellectual properties as a requirement for the PRTS to be finished. So you get the copyright in the Sudan and also the UI in the legal activity. And we have 2 agreement with the NDA domain to produce the tool and also the Sakura machines. And here the industrial project Sakura. So maybe we compare with the current tier 2. We can compare with actually this one we run inside their production line. We compare their tool and our tool. Maybe our tool can comparable with their tool, even it can sustain up to 2,000 cycles. This is the rough value. So we can sustain as well. Means if you use our tool, you can save 30%. In Sakura, the main problem they spend 2.4 million a year for the tool itself. Because this tool you use and after you wear, you throw away. So means 2,200 or up to 3,300 K per month. So if you use our tool, better where you can save 90 K per month. We can have up to 2,000 punya cycle. So here the method of we testing in our India line in Sakura machining. And here for outcome for the first project on the green tool. So we have one FIGS, one REX, one PIGS here, and here exhibitions on the high tech. And also this one for the peace and also the activities in Russia. So here the paper, the 3 paper, and the graduate student mainly 1 PhD, 3 masters, and then 3 PhDs given. So before we go for the next project on the tool, so we can have this a process cutting comparable on the two different tools on the easy pocket cutting. The second project is mainly on the milling tool. We use for drilling tool. So this is basically the drilling. So this project related to the Miyazu problem on producing hot press forming sheet metal based on wrought steel, where heat at the absolute temperature before it rapidly quench it. So we use a tool with cooling inside on it. So in order to produce this cooling, so we use this heat cooling tool. And whereas the problem, we will have a higher rate and higher productivity, the main problem. So we will have toolware and implementation. So we produce our online tool together with the tool. So the objective, produce online monitoring and also have optimum tool geometry. So the first experiments based on cutting speed, feed rate and depth of cut. So we produce the result of the accelerations from the tool and also from the piece itself. So we can define each one either good or not good tool conditions, tool wear. You have this kind of tool conditions, and a good small wear, medium wear, larger wear, fracture wear. So from these classifications, we set the threshold to our condition monitoring systems, okay, based on X, Y, Z geometry. Even you will see X and Y in the same direction, but actually we give you different result, and also the FFT different. So based on this value, we have our algorithm put inside the problem here, and we test again, okay, to see it can detect or not the applicability during the tool. We try to prevent from big gauge fracture. So early monitoring is better, and here our behind the features of the GUI, and here our system to detect on it stable, unstable of the tool, and this is just a soft tool. And the more important is our tool geometry. So we use tool geometry with different point angle. So the detail of point angle is here. What is point angle? is the angle of the sharpness between 1 to 1, and we will have your helix angle and also the chisel edge angle, where we define and change it accordingly based on this parameter and create our design experiments of 27 experiments. So we study about their main effect, and at the end of it we will get this ANOVA, and we can choose which one give you the lowest kurtosis value. So based on kurtosis value and also the dilution method, so we can get 125, 35 and 120 the chisel angle, and other two geometry which give you the lowest kurtosis value, means the lowest vibration signal from the experiment. So these two can be defined from this second research on the tool. So where it means a certain event on the INEX, also secret, also ITEX, and also this one we get our e-science grants and got one IP on it with interventions, and also 3 journal, and the collaboration mainly from Yazoo itself and also the company who manufactured our drilling tool. So this is very deep drill, because the definition of deep drilling means the length divided by diameter is more than 16. And the last part is on the bone drilling. The bone drilling is the latest one we did with one PhD student. So mainly for these sections, we divide into motivations, material methods, result discussion, and the conclusions. So for motivation, we have introduction, what the problem, objective, teacher review. So mainly the bone drilling can relate to the common procedure in the health or medical departmental, where they will use either for fixings, implants, or protective installations. However, the problem is when you drill something, when it exceeds more than 47 degrees within 5 minutes, it will kill the cell. I mean, you have the osteonecrosis problem. So it's not good, because it will cause the problem of the blister, the bone edema, and also large bone defects. And also it will make our fixture loses, because the cell is not work anymore as a live cell, because it will kill the cell. So how to prevent this one? So we try to study on it, mainly on the simulation, but before that we compare the bovine and also the porcelain, which one is suitable. We can use our human bone. So first we compare, we get our result. Maybe the bovine is almost similar behavior with the human bones. So we use cow or the bovine as replacement to the human bones, and also we try to optimize similarly the cutting process parameter and also the geometry before we combine both to get better result of lipids. So this mainly the literature they put aside of contradict influencing of their geometry, either two geometry. They focus point angle and point angle. But in our cases, we add with the web thickness. Web thickness means the core of the tool itself. So the tool study where very close to us is Shah, and also next one is Saha. So we compare very close. So mainly we study about simulations. We use deform software for simulations. First, we study about the stability of the range, cutting range, or cutting drilling parameters before we optimize the drill bits. So here our simulation of the bolt, we just make it in a cylinder with a certain size, which is suitable for drilling simulations. We can have the real tool here for drillings with normally exactly as the drilling operations. Okay, here the result. When we drill, you can see the temperature will increase up to a certain point. It takes around 1 week or 2 weeks of simulations. You can see the real thing when we have cross section here, where you can see the temperature of the bolt itself will increase up to certain value to cause the bolt necrosis problem. Okay. From that simulations, the most novelty study is how to calculate the necrosis diameter and also the necrosis depth. So based on the simulation result, we need to count on it together with the maximum temperature. So we need to count the necrosis diameter and also necrosis height. So based on the calculations, we also compare with the experimental. You can see the differential almost less than 10%. So we cut cow bones, okay, and then make it clearly before we make it experiments using thermocouple, okay, to see the temperature difference. So from that statistic, as I said, how to calculate the suitable range of temperature, the range of the speed, and also using the response methodology to calculate which give you the minimum minimum temperature to prevent the bone necrosis. So this is the result of study. Okay. From the temperature, depth and also height. Okay, here the result, you can see the difference and make some calculation, some upgrade on it, okay, to see. And then we will get the suitable rotation speed. So we study our rotation speed between 50 to 500 and also feed 0.16 to up to 165 before we optimize the drill bits geometry, okay, on the unit point angle and also back thickness. And here our analysis of the parameters. So we will get optimum one, maybe the lower rotational speed, and the feed, which gives you the lowest temperature or the lowest diameter and lowest depth of the osteoporosis. And then the last one, optimize the geometry. Okay, the geometry will get around 131, 126 and 11% of wet thickness. We give you the lowest necrosis effects, and then we combine together, and you can see the difference between our method and other method. Where you can see our method almost we can see no opposite diameter and also no depth of necrosis, and the temperature still the lowest compared to other parameters in the literature. Similarly, when we combine both cutting parameters and also design, okay, when we compare the existing surgical drill with our drill, which is give you the better in terms of that three objectives. So similarly, when you apply both, you can see almost our tool, okay, cannot produce anything compared to the current one happening in the market. So when you compare with Zamsha, okay, our tool is better, okay, also with the existing surgical tray for the both objective of minimum temperature, okay, minimum diameter, minimum depth. So that's the last project on this tooling to achieve that three objective on the cutting process optimizations. But the most important for this talk, we focus on the optimal two geometry of the three of bones. So the main output for this research is publications. You can see you have 6 publications, 2 for Q2, 1, Q1. Okay, that's the main output from the research. And the next future and current research we are looking for, okay, these 3 research. The first is from the right side, chip breaker for turning. This will deal with Sakura machining. They have problem with continuous chip while turning the automotive product, where this continuous chip will cause the wear of the tool and also causes problem when you have continuous chip. So we have one PhD student now, and the second project is for the middle one is a micro ball milling. We try to create the deeper structure. This one we have visited last 2 years to the Japan, to the NS2. Okay. The student responsible is our fellow from our staff from FKP, okay, Muhammad Ali Hanafiah, who did this micro mill optimization geometry. And the last project, okay, we will deal with the dicing blade optimization. The dicing blade is really on the micro electronic product to produce the LED module. So this tool actually made from nickel and diamond. Okay, the price around 300 ringgit. The problem is the lifetime is so low compared to their standard. The standard should be 4,000, 4,000. However, up to 2,000, okay, already wear. So we like to see this matching ground with Lumileds, Penang, okay, to see our method on improving or introducing new coating in order to enhance their lifetime. Okay, I think that the conclusions, okay, we have 3 tools, current development on the milling tool, drilling tool, and bone drilling. And this just my journey from 2010, teaching lecturer 2014, supervisor, and last year get professor. And for this year, achievement, mainly we bring the UAT University to give Global College Award to our late Prof. Masita, okay, in the Middle East. Prof. Wabuji, their president, who very supportive for collaboration between UMP and UAT. So I try to bring UAT to this faculty so we can have strong collaboration in our research, not only in terms of this dynamo and tool, maybe other research which can have enhanced our collaboration. So next project is on the Lumileds. Okay, we have MOU. Okay, it's due to we have our staff here to move from FKP, who are the CEO at faculty, okay, 2.0, who work there for 6 months. So we try to have this collaboration on to get the assembly to project. And the next project, okay, this one on the model development. This one will deal with the Firdaus. We have several projects. So my part, we need to develop TVET training to I proposal to the technician, to the polytechnic lecturers. Okay, we propose our module on the smart machining process. So we developed the module, and they give quotation work around 42K. So this one we did should be on the March, however due to COVID-19, so we just finished on the August. And the last, this is on September, we do have webinar UMP DEWAN virtual postgraduate conference. Some of our postgraduate from this faculty join this event together with DEWAN. So 10 from Colloqium Engineering and 7 from DEWAN join this conference virtually, because they actually every year they will come on summer vacations in UMP. However, due to COVID this year, so we just can have this kind of collaboration in terms of webinar series. And the last project is on the matching grant with TT Electronic, which amount about almost 100K. So it's still in progress. So I think that's all. Okay, my collaborator doing 10 years work in UMP. I think that's all. Okay, thank you.
Thank you, Prof. Marazan, for interesting presentation and really comprehensive research from mentioning field that he is in, from automotive industry to healthcare components. So the output of his research is really interesting and encompass a lot of manufacturing interest.